What's up, everybody? Welcome to a recording describing the chemistry compound project that Dr. Rogalski and I have assigned to you for these last few weeks of digital learning this year. This project is due on either June 4th if you are an X-Day Chem student. Just in case you know, you don't know, the X-Day Chem students are Dr. Rogalski's class and my classes during periods 7 and 3, and it is due on June 5th, the last day of classes, if you are a Y-Day student, which are my periods 4 and 6. This little project is just kind of a way to wrap up the digital learning. It involves pretty much everything we've talked about, a little bit at least, in the second semester, and everything we've talked about on the digital learning. So it's kind of a nice little way to sum it up. And what has happened is you are assigned a ionic compound with a polyatomic ion inside of it, and then you have to research that compound for various different things. If you take a look at it, all right, you're making a slideshow presentation. I would recommend Google Slides if you're comfortable with it, but if you would rather use Microsoft PowerPoint, feel free to use that instead. If you know of some other presentation software that makes something very similar to this, or something very similar to a slideshow presentation, you may use that as well. And you're essentially making 6 slides of content and 1 slide of references and resources that you used. All right, I'm going to go slide by slide, just kind of giving you an idea of what you are doing. The first slide is just introducing your compound. That's where you're going to put the name, the formula mass, what this compound is like under normal conditions. So normal conditions would be 25 degrees Celsius, about room temperature, 25 degrees Celsius, and 1 atmosphere, or 100 to 101.3 kilopascals. That's standard pressure. So like room temperature, standard pressure. And whenever you look up a compound or an element for that matter, it will give you what it appears as under normal conditions. So is it normally a solid, a liquid, or a gas? All right. I'm going to go out on a limb here and tell you most of yours are going to be solids, but it should be easy to look up. Final thing you need for slide 1 is just a picture of what the compound looks like. All right. The important thing here is to keep that detailed list of sources. All right. Copy and paste full web addresses. So if you get your picture from somewhere, cite the source where you're getting your picture from. All right, I doubt you are going out and finding some of these compounds around your house or your neighborhood and taking pictures of them, so just give credit where credit is due. Second slide is all about the electrons in the compound. All right, your compound contains a polyatomic ion, so there are at least 3 elements in your compound. There might be 4. Maybe under the rare circumstance there's 5, but for each element, write the electron configuration. That's that 1s2, 2s2 stuff. All right, you can use the abbreviated, which, it's something we did early in the 3rd marking period before we did distance learning. That's where you would put noble gas in brackets, and then, do the 3s2, 3p4 as you would to get to the different, show the different electrons. Do an orbital filling diagram. That's where you draw the boxes with the arrows based on your electron configuration. All right, so the orbital filling diagram, an S gets 1 box, a P gets 3 boxes, a D gets 5, and so on. And then you put the arrows in there. Each arrow represents an electron. You half fill the boxes of the same letter first. So if you have the 3 P boxes and there's 3 electrons, you put 1 arrow in each box. And finally, the Lewis dot diagram, where you look at just the S and P electrons from the orbital filling diagram, and you put those dots around the symbol. And finally, draw a Lewis structure for the polyatomic ion. That is something we did right near the beginning of this distance learning stuff. So there are videos of mine back in your chem class in the different folders, so you can kind of brush up on that or go check your notes. A lot of these polyatomic ions you may have drawn once already, and also the internet's at your disposal, so you can probably find some of these and double check your work that way. All right, it's best if you probably try to get some of these slides done at a certain time. The third slide is just physical properties of the compound. All right, so you're going to just want to try to find a good source of a bunch of general information about your compound. And I'm looking for the melting point with units, the boiling point with units. Not all of you will have a boiling point. So if you don't have a boiling point, just like say no boiling point available or N/A or not applicable or something. List any of the common hydrates you can find. So if you take your chemical and put it into Google and search your chemical name, common hydrates, you should be able to figure that out. Again, full web addresses. You should be able to find the density with the units, the solubility in water with units, how soluble it is in water, how many grams per milliliter of water or something like that. The specific heat for as many phases as you can find. You should at least be able to find the specific heat for the solid and possibly the liquid. Not all of these you'll be able to find a specific heat for gas, but for as many of them as you can find. And finally, the heat of vaporization or the heat of fusion. One of those for your thing as well. In fact, so there's actually a typo on here. This right here. It should be heat of fusion. All right, let's move on to the next slide. Those first three slides you should hopefully have done by Monday the 25th. That is next week, Monday. That's Memorial Day. You don't have to submit it or anything. This will just keep you on a good pace to make sure you have everything done in time. All right. The fourth slide is probably the one that's going to take the most amount of time. You have to generate a heating curve. So that is one of those graphs that looks like this, where you're heating a solid, the horizontal line is melting, and then you're heating the liquid. A couple of things. You are starting at 5 degrees Celsius, at which case every one of these compounds would be a solid. And you're going to heat it till it's 10 degrees above whatever the melting point is. So your final temperature at the end of the graph is going to be different depending on what compound you have. All right, the shape of the graph should look the same. You're going to put the starting temperature, melting point, it says boiling point, but we're going to get rid of that. Oops. Starting temperature, melting point, and final temperature are all going to go on the y-axis. So you're going to have 3 values on the y-axis. One right here for the melting point, one right here for starting, then the melting point, and then the ending temperature there. And you're going to do 3 calculations. You're going to calculate each part of the graph. This first diagonal is a Q equals MSHAT equation. The horizontal line is a Q equals MH fuss. And finally, the last one is a different MSHAT. There's going to be a different specific heat because you're using the liquid. If you have trouble finding the specific heats of your liquid, all right, pop into office hours or send myself or Dr. Rogalski a message, depending on who your teacher is, and we will try to help you find that. Slide 5 is to write balanced equations for 5 reactions your compound could be involved in. All right, you can make these up on your own. You can go find real ones. All right, and then you just have to identify the type of reaction. Yeah, I kind of know this is more first semester stuff, but it's good stuff to remember how to balance equations and what those different equations are. So that's why we're going to kind of keep those going. All right, if you can get those 2 done by the end of May, you'll really only have 1 slide left if you've been keeping your detailed list of sources. Slide 6 is just uses and fun facts. So I'm looking for 2 ways which we use your chemical. Try to make them as modern as possible. All right. Some of these chemicals, get used for various things and haven't been used for what they're used for now or whatever. But try to use modern uses. All right. If the use says something like etchants and printed circuitry, you might want to know what that means, and that explains this. So pick uses that are, self-explanatory, something that like an 8th grader could know on their own, or a 9th grader could know on their own without having to look anything up. If it's a little more complicated, if your chemical gets used in more complicated things, just give a little explanation about what that means. All right, let me know you did a little bit of research about how these are used and you didn't just copy and paste. The 2 fun facts, just 2 facts about your compound that haven't been listed before. All right, maybe your compound was originally discovered by some crazy way, so that would be a fun fact. And just because it says fun in fun facts doesn't mean it actually has to be something that's really fun. Your definition of fun and my definition of fun are completely different. There's a good chance you will think none of this is fun. All right, but I'm a big dork and I love chemistry, otherwise I wouldn't teach it. So a lot of like little facts about things are kind of fun to me. All right, all it has to be is a fact. All right, 2 facts that you haven't gone through before that, are kind of neat. All right, don't just say, like, a fact is it contains carbon. Well, that's kind of given in a chemical formula. All right, and so 2 ways compounds used, 2 fun facts, and then the final thing is the resources. All right, just copy and paste full web addresses. All right, you may use your textbook as a resource as well. Remember, just put the name, the author, and the publisher. All that can be found at the beginning. All right, and I'm looking for a minimum of 4 sources. So you're not going to be able to just say textbook and Wikipedia. You need to go a little deeper. All right, 4 sources isn't a whole lot. Copy, paste those pages on there. And that's it. All right. The next 2 parts of this presentation and the PDF handout, this is just the rubric. You can see each slide is its own category. Each slide's its own category right here. So, you know, figure out how to do really well. These needs improvement slides, yeah, there's grade ranges. The Schoology rubric won't show grade ranges, right? So I took the average, essentially, of those. But what I will do is, there's a sliding scale of needs improvement. The worse the slide is, the lower it might get in there. But as long as you are finding these things, you can pretty much grade this yourself. Do you meet all the requirements for the excellent or good points? And then you can kind of grade it. It's out of 100 points. With this project, it'll make over 800 points for the marking period, I believe, or really close to 800 points for the marking period, I believe. So, the only way this will significantly destroy your grade is if you get worse than a 50, or if you just don't do it and you get the 0. If you're doing a decent effort and you're landing yourself somewhere in the 85 or above range, this should not cause a drastic reduction in your grade. And if your grade is somewhere in the 70s right now, this can help boost it. The other thing that can help, turn in old stuff. All right, Dr. Rogalski and I are both taking any work from the 4th marking period. Yeah, there's a sliding late scale, but the zeros really kill your averages, guys. All right? And the 4th marking period's half your semester 2 average. So you really want to get a decent 4th marking period grade, and then you're going to just totally rock out this semester. All right? I'm not going to go, oh yeah, I can. So here's the last slide of the rubric. On this one, we can see Dr. Rogalski's period 5 class. So find your name. It's the element right next to the name. All right. You can then, the next page, which I won't go to, those are my 4 classes. All right. I posted these for my classes, at least in the daily updates. I linked this file to those daily updates, and this is in the weeks or the days 17 to 23 or whatever days we have left. All right. I do know one little difference between Dr. Rogalski's class and myself is I'm going to have just a mandatory Zoom check-in next week, the week of May 25th. All you have to do is pop in during your class time or office hours. I'm pretty much going to be sitting around twiddling my thumbs on Zoom during class times and flex, just checking off people when they pop in. And if you pop in, you're good. I might ask you a couple questions, see how the rubric's doing, see how you're doing. And what I want to do for my classes is I'm going to have a Zoom on that last class day. I'm going to keep it kind of short if you guys want it short, and just kind of pop in and try to get some closure for this craziest year ever that we've kind of had here. And that's about it. So that's all I've got for you. Get this done. Turn in late work. And, that is it. So guys, take it easy. Reach out to myself or Dr. Rogalski if you have any questions. All right. And if you follow the timeline, I don't think this should take you all that long at all. And you should kind of get to where you need to be quickly. All right. Have a good one, guys.